This video is part of my complete practical CCNA course where I'm showing you how to configure Cisco devices in preparation for the CCNA exam, but I'm not using emulators or simulators. I'm using real Cisco devices such as the Cisco 9200CX switch. In other words, I'm not just using old devices, I'm using very modern Cisco devices to show you how things actually work so that you can pass the CCNA exam, but also go out there and make a success in the real world. In this video, I'm going to show you how to hack a network using a Python script. Now, in this example, I'm using physical Ethernet, but the script can also be used on a Wi-Fi network. You need to understand how ARP works for the CCNA exam, but also for the real world. In this video, we're going to be covering Dynamic ARP Inspection. This is part of 5.7 in the CCNA version 1.1 exam. In this first video, I'm going to show you how to hack ARP using a Python script. The Python script is going to be used to hack this physical network using physical Ethernet connectors, but the same Python script can be used to hack Wi-Fi networks. So in this first video, I'll show you how to hack ARP, and in the next video, I'll show you how to enable Dynamic ARP Inspection to stop this kind of nonsense. Now, you don't have to learn Python for the CCNA exam, but I highly recommend that you do learn it for the real world, and a great place to learn Python is Brilliant. They have many courses, including Programming with Python. This is a level 2 course, or Applied Python, which is a Computer Science and Programming level 4 course. What I really like about Brilliant is their content is very interactive. Rather than just passively watching a video as an example, you are involved in your learning. So as an example, can you solve this question? Number equals 2, print number plus number plus number. What's the answer? Answer in this example would be 6. And there you go, I got that right. I'll click continue. What about this one? Length equals 10, width equals 12, print length by width. What's the answer? Answer is 120. Notice how interactive this is. Now you may find that those questions are too easy, but notice as you go through the training, the questions get harder as you go deeper into Python. As an example, they have a section, practice conditions in loops. So this is a little bit more difficult. What condition should be inserted on line 2? The output should classify even and odd values. So for n in range 4, add a condition here, print n is even, else print n is odd. What's the answer? So I'll just randomly check that option, and notice we told that that's incorrect. The correct answer is this. Again, notice how interactive the training is. Brilliant to take you through different modules, starting at the beginning, going deeper and deeper into Python. I highly recommend that you learn Python for the real world. Brilliant, once again, is a great way to start your journey. Use my link below to get a special discount. I really want to thank Brilliant for sponsoring this video and supporting my channel. My free CCNA course wouldn't exist if it wasn't for sponsorships from companies like Brilliant, who are really a brilliant company to work with, fantastic partner. I really want to thank them once again for supporting me and helping me create more free content to hopefully help you change your life. To try everything that Brilliant has to offer for free for 30 days, visit brilliant.org/David Bombal or scan the QR code on screen or click on the link in the video description. You'll also get 20% off an annual premium subscription. This is what our topology looks like. I've got a Kali Linux virtual machine running on this Windows computer. It's connected to the 9200CX switch on gigabit 101. Right over here, I've got a Windows 11 computer, that Windows computer at the top there. It's connected to gigabit 1011 on the 9200CX switch. And then I've got a Cisco router over here connected to gigabit 102 on the Cisco switch. Now, ARP is required in Ethernet and Wi-Fi networks because devices need to learn the MAC address of the devices that they're communicating with. As an example, if this Windows computer wants to send traffic to the internet, it will need to know the MAC address of the router so that frames can be sent on the Ethernet network. So at layer 2 in the OSI or TCP/IP model, we've got Ethernet. It's going to be using a MAC address. At layer 3, we've got an IP version 4 address as an example, or IPv6. When this Windows computer sends traffic onto the internet, for example, going to google.com, it needs to know the layer 2 MAC address of its default gateway. And what we're going to do in this topology is hack that so that the Kali Linux machine replaces the MAC address used by Windows 11 to get to its default gateway. So what's essentially going to happen is traffic is going to be sent via Kali to the router to get to the internet, allowing us to sniff all usernames and passwords and any other traffic that's sent in clear text. This is why you don't want to use clear text protocols in today's networks. You want to use encrypted protocols. So as an example, you want to use TLS rather than HTTP. You want to use SSH rather than Telnet. A very bad idea to use these kind of protocols in networks today. Now, talking and PowerPoints are okay, I suppose, but much better, I think, for me to demonstrate this practically. So on my Windows 11 computer, at the top there, I'll open up PowerShell, type ipconfig. What you'll notice is Ethernet 2 on this computer has this IP address, 192.168.1.6. That IP address was allocated by this Cisco router using DHCP. So on the router, if I type show IP DHCP bindings, you can see this IP address was allocated to a device with MAC address ending in D321F. So on this computer, let's do ipconfig/all. We can see more information now. Ethernet 2 has this MAC address, D321.3F. And again, that's the MAC address we see in DHCP. So that IP address was allocated to the Windows computer. We can see IP address here. We can see default gateway. We can see DHCP server. Notice default gateway is 192.168.1.254, which is the Cisco router. So VLAN 1 on the Cisco router has this IP address, 192.168.1.254. What I've done here is connect the switch using this gray cable to one of these ports on the Cisco router. These are layer 2 ports, as in the router has a built-in switch. So hence the IP address being configured on VLAN 1. Show interface VLAN 1. What's important to note here is the MAC address. It ends in A674. On the Windows computer, I'll clear the screen, type ARP-A. 192.168.1.254 has a MAC address ending in 12A674. So the PC has learnt the MAC address of its default gateway. Default gateway, once again, has this MAC address 12A674. So when the Windows computer goes to a website such as davidbomble.com, that traffic is going to be forwarded via its default gateway. So once again, the Windows 11 computer, to get to the internet, is sending traffic to its default gateway. We are now going to manipulate that using a Python script so that traffic is forwarded to Kali and then on to the default gateway, allowing us to capture all traffic sent between Windows and its default gateway. Now just note, you don't have to know the Python script for the exam, but hackers can easily use a script like this or other applications to intercept traffic on layer 2 networks, both wired as well as wireless. So on Kali Linux, over here, I'm going to open up my home directory. What I want you to notice here is there is no PCAP file shown at the moment. But when we run our Python script, it's going to capture packets and save those packets in a file, allowing us to view usernames and passwords and other information sent in clear text. So I'll open up a terminal. ls shows us the script ARP maninthemiddle.py. It's a fairly long script. This script is available on my GitHub. If you search for David Bomble, Red Python scripts, or ARP man in the middle Python script, you'll find this script and you'll be able to copy and download it. As always, only use scripts like this for testing and evaluation purposes. Only attack networks that you own or have permission to attack. Now, we told in the script that we have to use this command, sudo to give us root privileges, Python 3 to run Python 3, the name of our script, and then we have to specify an IP range that we're going to attack. So in our example, it's going to be 192.168.1.0/24. This script uses SCAPE and a bunch of other options to capture packets off the wire and change the ARP caches of our computers. Again, you don't have to know this script for the CCNA exam, but for the real world, I'd strongly recommend that you learn Python. So here I'll type less ARP maninthemiddle.py .py. And as you can see there, here is our script. And again, I won't bore you going through the entire script. You don't need to know that for the exam. So type sudo python 3 ARP man-in-the-middle.py. Our range is this because on our DHCP pool, if I type show IP DHCP pool, that is the range of IP addresses that are being allocated via DHCP. Now, just before I run that script, notice on the Windows computer, if I type ARP-A, our ARP cache is showing that this IP address is mapped to this MAC address. But that's going to change once we run our Python script. Sudo python 3, our script, and our subnet. I'll put in my sudo password. And what you'll notice now is that we asked to specify the device that we're going to attack. So the device that I want to attack is 192.168.1.6. That's once again this Windows computer. If I open up a new tab here and type ipconfig, notice IP address 192.168.1.6. And if I look at the MAC address, it ends in D3213F. And there it is. So I'll select 0 to attack that device. And notice it says writing to pcap file, press Ctrl-C to exit. So if I have a look at my home directory, notice this requests.pcap file has now been saved. And if I open that up with Wireshark, you can see a bunch of traffic is being sent into the network. So we can see ARP traffic here, a bunch of ARP messages and other messages are being sent into the network. I'll close that down and let the script run. What I want you to notice, and this is the important piece, is previously, this IP address was mapped to this MAC address. If I open up another tab now and type ARP-A, what you'll notice is this IP address is now mapped to a different MAC address. So previously, it was mapped as follows. Now, it's mapped to this MAC address, ending in 5ED91C. And if I open up another command prompt on Kali and type IP address, what you'll notice is that's the MAC address of the Kali machine, 5ED91C over there. That means that we've poisoned the ARP cache of this Windows 11 computer, making it believe that Kali is the default gateway. So it believes that 192.168.1.254 is using this MAC address rather than the real MAC address. So all traffic will therefore be sent via Kali to the internet as an example. Now, how is the Python script doing that? We can see what's going on by opening up a Wireshark capture on the Windows computer. The interface that has this IP address is Ethernet 2. So I'll capture traffic on Ethernet 2. I'll zoom in here a bit. And what you'll notice is there's a bunch of traffic being sent, but the important piece is ARP. What you'll see here is VMware is telling Dell, that Dell computer at the top, that 192.168.1.254 uses this MAC address 5ED91C. So we are basically poisoning the ARP cache, saying that this IP address is using this MAC address. But in actual fact, this IP address is configured on the Cisco router, not on VMware. So the Dell computer with this IP address 192.168.1.6 thinks that 1.254 uses this MAC address. It's as simple as that. We are basically poisoning the ARP cache of the Windows computer. I'll stop this capture so that it looks like this. Now, this is known as a gratuitous ARP, where a device, in this case, the VMware virtual machine, is updating the Dell laptop with its new MAC address for this IP address. So it's basically telling the Dell device, update your ARP cache with this new MAC address for the mapping of IP to MAC address. Now, there are legitimate uses for this. If a device changes its MAC address, as an example, it needs to tell devices on the network what its new MAC address is. So it would send out a gratuitous ARP like this. But in this example, this is used maliciously because Kali Linux running within VMware is telling the network that this is the new MAC address for this IP address, which is obviously incorrect. The MAC address for 192.168.1.254 isn't that. It's actually this MAC address. So we are attacking or poisoning the ARP cache on the Dell machine so that it sends all traffic to the Kali machine instead of to the local router. Okay, that's all right, but let's try and do something. So what I'll do is open up PuTTY on the Windows computer, and let's assume the administrator did something really dumb and allowed Telnet to the Cisco router. So I'll Telnet to the Cisco router, to its loopback address. On the Cisco router show IP interface brief, we can see this IP address is configured on the loopback. So what I'll do is Telnet to that IP address, and we asked to put in a password. So I'll put a password in, put an enable password in, and let's type show run. So I'm basically showing the config of the router now. Really bad idea because I'm using Telnet. So on Kali, I'll open up this pcap file, and then what I'll do is search for Telnet. And as you can see there's Telnet data sent between 192.168.1.6, the Windows computer, and the loopback of the Cisco router. And we could go through this output and look for stuff. And what you'll notice right there, CISCO, that's the password on the VTY line. Here I pressed return. Notice the prompt is shown. Then I typed EN to go to enable mode, pressed carriage return. Router asked for the password. I put it in CISCO. So I've been able to capture the passwords. It's a lot easier, however, to go to follow TCP stream, and right over there you can see the password, Cisco and Cisco. Okay, that might not be so clear, so what I'll do is copy that and I'll paste that in here. So scrolling all the way up, there's the Telnet password, typed enable. I'm capturing traffic in both directions, so I'm seeing the E typed from the PC to the router and the router echoing back the output. There's the enable password, typed show run, and notice here's the whole configuration showing the enable password. Scrolling down, all the config of the router is shown here, including the password on the VTY line. Don't use Telnet in today's networks. Okay, but let's make it even worse. Let's assume that we use HTTP to go to another router. So this is another Cisco router. It's actually connected on the other side of the Cisco router. So it's part of my lab. I'll type the username Cisco. And as you can see there, we can see some output of the router. Back on Kali Linux, I'll close this down and open it up again. And let's search for HTTP. So we can see some HTTP going to various websites. There's 1.6 going to 192.168.32.49, which is the one we're interested in. And we can have a look at the output here. We can see that it's Windows NT 10, 64-bit architecture. We can see that we're connecting to a Cisco router. Scrolling down, some information is shown here. The part that I'm interested in is authorization, credentials, Cisco. Those are the credentials for another Cisco router in my infrastructure captured by Kali because the traffic is going via that device to get to the router. So we can essentially see everything. Again, this is why you want to use encrypted protocols such as SSH or TLS. You don't want to use Telnet or HTTP in today's networks. This is another reason why you'll see warnings out there about using public Wi-Fi networks, because you could be connecting to a Wi-Fi network rather than a physical network. So your phone, as an example, could be connected to a public Wi-Fi network, and someone could be running Kali Linux and capturing traffic through that network. This script, once again, works on both wired as well as wireless networks. ARP is used both on Wi-Fi as well as physical Ethernet like this, so the script will work on both of those. So what we need to implement in our network is Dynamic ARP Inspection, where we validate address resolution packets or ARP packets in a network to make sure that we stop man-in-the-middle attacks. And I'll cover that in the next video. Hopefully you enjoyed this video. Hopefully you've learned something. Again, Dynamic ARP Inspection allows us to stop these kind of attacks where ARP caches are poisoned and hackers can run man-in-the-middle attacks to capture traffic on both a wired as well as a Wi-Fi network.